Hello everyone, welcome back. This is the fourth video of MCQ questions on signals and systems, and these 5 questions we are going to discuss now is based on even and odd classification of the signal. Without wasting time, we'll start with the first question. The first question says that condition for a signal to be even is option A, x of minus t is equal to x of t. Option B, x of minus t is equal to minus x of t. Option C, x e of t is equal to x of t minus x o of t. And option D, none of the above. Even signals, no? Even signals, those are symmetric. When I say symmetric, when you fold the signal across the time t is equal to 0, this is at t is equal to 0, when you fold this, the amplitude of both positive side of the t and negative side of the t, they overlap, okay? They overlap, something like this, if you fold this. Whereas odd signal, those are anti-symmetric. An example is sine wave. Sine wave start from 0, right? Now, if you fold this signal across time t is equal to 0, what happens? So they overlap, but they overlap in the opposite direction, something like this. So these are all, these kind of signals are called as anti-symmetric, and this signal is called as symmetric. Okay. Now, let us see the condition. So x of minus t, in the sense, if you have a signal, you take its mirror image, right, is equal to x of t. What do you mean by this? If you take the mirror image of the given signal, you will get back your original signal x of t. Okay. And what is this condition? This condition is for symmetric signal, right? So if I take this is this cosine wave, k is equal to 0. If I take its mirror image, I get back the same signal now. I get back the same signal. Okay. So x of t, and if I take mirror image of this, I get x of minus t. So both are same. Right? So if this condition satisfies, then the signal is even signal. So right option is option A, which is even. X of minus t is equal to x of t. But still, we shall look at this condition also. This is x of minus t is equal to minus x of t. This is condition for odd that we will look at in the next question. And this condition, no, any signal x of t can be decomposed into sum of odd component and even component. Okay. Any signal, arbitrary signal x of t can be decomposed into sum of even and odd component. From this, we can write x even of t is equal to x of t is, subtracted with x odd of t. Okay, so this is not the condition, but this says that any arbitrary signal x of t can be decomposed into sum of even and odd component. This statement is valid, but as per the question, the condition should be this. Okay, this is also not the right option, and none of the above is not the right option. Okay, so here the right option is option A, x of minus t is equal to x of t. Okay, we will look at the second problem. The second problem says this condition for a signal to be odd is A, x of minus t is equal to x of t. This cannot be the case because we already saw in the first question that this is for actually even, condition for even. X of minus t is equal to minus x of t. Option C is x odd of t is equal to x of t minus x even of t, and none of the above. Okay, so the condition for a signal to be odd is x of minus t. If you take the mirror image of the signal, you get back your signal back, but its amplitude will be negated. So let me convince you with a sine wave. Okay, so this is 0, this is t. You pick a point here, let's say t1. You pick a same point in the other direction also. Say this is minus t1, right? What is the amplitude? This is -1, and what is the amplitude here? This is +1. Now you pick a point, whatever the point you pick in this direction, in this positive side of t. Same point if you pick at the negative side of t, their amplitude will be ulta. If you pick here, its amplitude is something, it will be here. Okay, if you pick here, its amplitude is here. In the sense, what if you take mirror image of the signal? If you take mirror image of the signal, you get back your signal, but its amplitude is ulta. For example, if this is x of t, if I take its mirror image, look at the amplitude, it is in opposite direction, right? All these are in opposite direction. So this is what x of t, and this is what x of minus t, but x of minus t is minus x of t because these two amplitudes are in the opposite direction. Okay, so the right option is x of minus t is equal to minus x of t. Now we'll look at problem number 3. Problem number 3 says that the even and odd component of the signal x of t is equal to cos t plus sin t plus sin t cos t is option A, option B, option C, and option D. I'm not going to read out the option. This part is even and this part is odd. This part is even, this part is odd. This part is even, this part is odd. This part is even and this part is odd. So which part is actually correct? Okay. So for that we have to use the formula. The formula to get even component of the signal xe of t is half of x of t plus x of minus t. To get odd component of the signal xo of t is equal to half of x of t minus x of minus t. Okay, this is to get even and this is to get odd component of the signal. So we'll look one by one. X even of t is equal to 1 by 2 times x of t. But what is x of t? X of t is given here plus x of minus t. Do we know x of minus t? No, we don't know x of minus t, but we can get x of minus t using this equation. In x of t equation, wherever t is there, you replace it by minus t. Okay, so anyhow we have x of t, we'll get x of minus t. X of minus t is equal to, in this equation, wherever t is there, you replace it by minus t. What do we have? Cos of minus t plus sine of minus t plus cos of minus t sine of minus t. I have sine cos, but I put cos sine since it is multiplication, no issues, right? So x of minus t is equal to, what is cos of minus t? It is cos of t. Why? Because cos is a even function. Sine of minus t is minus sine of t because sine is a odd function, so it is minus of sine t. Cos of minus t is actually cos t. Sine of minus t is minus sine t. So I have plus, I'll make it as minus sine t. Okay, so this is x of minus t, which I have to put here. And what is x of t? X of t is this, which I have to put here. So what do I get? X even of t is equal to 1 by 2 into x of t. X of t is this, cos t plus sin t plus sin t cos t plus x of minus t. X of minus t equation is this, cos t minus sin t minus cos t sin t. Okay, so cos t sin t plus cos t sin t minus cancels out, plus sin t minus sin t cancels out. So I end up with cos t plus cos t, 2 times cos t, 2 times cos t by 2, 2 cancels out. So what I get as even function as x even of t is equal to cos t. Okay, so either this has to be the right option or this has to be the right option. We'll see out of these two which is the right option. Now in order to find the odd signal xo of t, as I told you, it is 1 by 2 into what? X of t minus x of minus t. So instead of using this equation, we will use this equation. As I told you, any arbitrary signal x of t can be decomposed into even component and added with odd component. We know what is the even component, we found it now, which is cos t, right? Plus add odd component should give me the signal x of t, correct? Now we know the even component, we know the x of t. If I know these two, I can get xo of t. How do I get it? You solve for x of t, xo of t. Xo of t is what? X of t minus cos t, right? Now what is x of t? X of t is cos t plus sin t plus sin t cos t minus this, which is minus cos t. So cos t cancels out. This is equal to sin t, take common, 1 plus cos t. So sin t 1 plus cos t. Okay, so therefore the right option is option A. Fourth question is, if x of n is odd signal, which of the following condition is true? Summation n x of n is equal to 0, summation n x of n is equal to 1, summation n x of n is equal to infinity, summation n x of n is equal to minus 1. So what is the question? If x of n is odd signal, again I'll try to convince you with a sine wave, because sine wave is a nice signal to convince you the properties of odd signal. This is discrete time, but I can convince you with the continuous time also. This is at t is equal to 0, this is t, and this is x of t. And let me take even component, even signal also. This is how the even signal looks like, right? It is symmetric. Now, if you sum it up, this and this portion cancels out, right? And this positive, this negative cancels out. This negative, this positive cancels out. This is positive and this is negative cancel out. So if you go on till infinity, what happens? Positives, negatives, positive, negative cancels out, and everything is cancelled out. What I get is 0. Therefore, summation in x of n is equal to 0 is the right answer. Even, no, this is not the case. You won't get 0. But for odd, this is the case where you sum it up all the amplitude, both in the positive side and as well as the negative side. So those two cancels out. What is the resultant we get is actually 0. Okay, we'll look at the fifth question. Fifth question says that even component of the signal x of t is equal to t 2 minus t square 1 plus 4t square is 0, t into 2 minus t square, and none of the above. No other option we have to substitute it in the equation and we have to find it out. So even component, right? So what is the equation to get the even component of a signal? X even of t is equal to 1 by 2 into x of t plus x of minus t. What is x of t? X of t is equal to, we'll simplify it. It's better if we simplify it so that getting the even and odd components is easy. So what do we have? T 2t minus t cube and 1 plus 4t square. And if I substitute it, simplified 2t minus 1, 2t, 4t square into 2t, and this is positive. This is 4 to the 8 t cube minus t cube minus into plus minus. This is 4 t power 5. Okay. Now this, what is this? X of t. Similarly, we get x of minus t. How do I get x of minus t? In x of t, wherever t is there, you replace it by minus t. So minus of 2t, this is odd. I get minus of 8 t cube. This is odd. Minus into minus plus t cube plus 4 t square, t power 5. Right. So what do we have? X e of t is equal to 1 by 2 into x of t is 2t plus 8 t cube minus t cube minus 4 t 5 minus 2t minus 8 t cube plus t cube plus 4 t to the power 5. So plus 4 minus 4 plus t cube minus t cube plus 8t cube minus, this is plus, this is minus. So everything cancels out. So I get even component x e of t is equal to 0. Therefore, the right option is A, which is 0.